Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video, we're going to be really focusing on the calculations that we see involving the mole. Now, we talked about what the mole was and the origin of the mole in the previous video in this unit, and I would highly recommend you watch that video before you come and watch this video, because the concepts in the previous video are really going to help you understand the concepts within this video. So before you even try to attempt these problems and try to understand what I'm saying, go check out the last video. Make sure you have that you have the concepts there really well learned. Okay. So from the previous video, we should be able to answer this question. 1 mole of neon atoms has a mass of. Okay. So we said that 1 mole of a substance of any elements, the mass of 1 mole of that element, and by the way, 1 mole is 6.022 times 10 to the 23rd atoms of that element, is equivalent to that many grams, given the atomic mass. Okay, so that's kind of confusing. So if you're looking at 1 mole of neon atoms, or 6.022 times 10 to the 23rd atoms of neon atoms, you just go to the periodic table and you look at the average atomic mass of neon, and it says here that the average atomic mass of neon, kind of hard to read here, it's 20.190. So given that the average atomic mass of neon is 20.190, you can deduce that 1 mole, or 6.022 times 10 to the 23rd atoms, same thing, of neon, is going to have a mass of 20.190 grams. Okay, and we talked about how this works for every single element in the previous video, so go check that out. There's actually a nice proof that I did there. Okay. Now, when we're talking about calculations with the mole involving atoms, there's typically this basic thing here. So you're going to be asked to convert from any of these three things, okay? Atoms, moles, and grams. So this little chart here really can help you convert between everything. So like, for example, if you wanted to convert from grams of an element to atoms of an element, you'd first use the periodic table and use what I did right there to convert from grams to moles. And then once you get to moles, you can use the fact that 1 mole is 6.022 times 10 to the 23rd atoms and get to atoms. And we're going to be using this chart back and forth in the next 9 problems that I'm going to work out for you here. So this will make more sense. Okay, so first one here, 2 moles of neon atoms that has a mass of. So whenever we do problems like this, whenever in any stoichiometry problem, you really want to use dimensional analysis. Now I have a very good video on dimensional analysis in the Introduction to Chemistry video, so if you've never heard the word dimensional analysis, go look up that video. Very helpful. Okay, so this question is saying 2 moles of neon atoms has a mass of. So we start with what we're looking for. So we're looking for the mass of neon atoms, and we're given 2.00 moles of neon. Okay. So let's look back at our chart here. If you want to convert from moles to grams, we're going to have to use the periodic table and use our conversion factor. Okay. So just like how we learned here, we learned that 1 mole of neon atoms has a mass of 20.190 grams, so we can use that as a conversion factor. So 1 mole of neon has a mass of 20.190 grams. Okay, so excellent. So now that we have this conversion factor, we can see how the units cancel out. Moles of neon cancels out with moles of neon here at the bottom, and we're left with grams of neon here. So from here we can just multiply everything we want, and we will get 40.380 grams. But we're not done. We have to account for significant digits, very important. Okay, so when you're looking for significant digits here, we're going to pay attention to 2.00 as well as 20.190. We're not going to pay attention to the 1 here because this is an exact number. Write that down for you. This is an exact number. And if you remember back from significant digits, an exact number is a number with an infinite number of significant digits, so this does not matter. Okay, so we're only looking at these two numbers here. This number has 3 significant digits, this number has 5. And since we're doing multiplication and division, we're going to look at our answer needs to have the lowest number of significant digits of our numbers that we multiplied and divide. So since that number is 3, our answer needs to be rounded down to 3 significant digits, so we're going to round this down to just 40.4 grams of neon, and we're done. Okay, pretty simple. Let's move on to our next problem here. So 0.50 moles of carbon atoms has a mass of, okay, so again, we're going to set up here, we're looking for mass of carbon atoms, so grams of carbon, and we're given 0.50 moles of carbon. Okay. Now for a conversion factor here, let's look back at this chart. If we want to go from moles to grams, we're going to have to use the periodic table. So the periodic table tells us that if you look at the number here, that average atomic mass of carbon is 12.011. Therefore, 1 mole of carbon is going to have a mass of 12.011 grams. So 1 mole of carbon is going to have a mass of 12.011 grams. And then our units cancel out nicely, like this. Moles of carbon cancel out with moles of carbon, and we're left with what we wanted, grams of carbon. And then we can go ahead and multiply here. And when we do that, let me make sure the calculator, we'll get this number. Our answer needs to be rounded down to 2 significant digits because this number here has 2 significant digits, this number has 5, go with the smaller one, so we will just round this down to 6.0 grams of carbon. Okay. Now, here, we're given that 32.0 grams of sodium is how many moles of sodium. Okay, so we're looking for moles of sodium, and what we're given is 32.0 grams of sodium. Okay, so if you look back here, we're going from grams to moles. Let me make sure we're doing that. Yeah, we're going from grams to moles. So in order to do that, we have to look at the periodic table. The periodic table, if you look here, tells us that the kind of hard to read here. Let me zoom in a little bit so we can might get a better view. Seen on the as you can see on the periodic table here, the average atomic mass of sodium is 22.990. Therefore, the 1 mole of sodium atoms is going to have a mass of 22.990. So I can use that as a conversion factor. So we put 22.990 grams of sodium here at the bottom, and then we have 1 mole of sodium atom, 1 mole of sodium here. So the reason I put this at the bottom is, again, we have to make sure our units are canceled out. If we put 1 mole of sodium atoms at the bottom here and put 22.990 grams of sodium at the top, we'd get the wrong answer because grams of sodium needs to cancel out with grams of sodium here at the bottom, okay? In order to get what we left out here, moles of sodium. So from here, we can just go ahead and multiply out. So 32.0 times 1, multiply the top, multiply the bottom, and divide the answers. So 32.0 times 1 divided by 22.990. 0 times 1 divided by 22.990. And that's going to give us this number right here. However, we have to pay attention for significant digits. This number has 3 significant digits, this number has 5, this number has an infinite number of significant digits, so we don't worry about it. So we go with the smaller number, 3. Our answer needs to be rounded down to 3 significant digits, so in order to round this number down to 3 significant digits, we just round it to 1.39. 1.39 moles of sodium. We're done. Okay, pretty simple. Let's keep moving. Okay, this question is asking 3.5 moles of sulfur is how many atoms of sulfur? So, again, good setup here. We're looking for atoms of sulfur, and we're given 3.5 moles. So from this chart here, you're going from moles to atoms. So this tells us that 1 mole of substance is 6.022 times 10 to the 23rd atoms. Okay, so we can use that as a conversion factor here. So 1 mole of sulfur is 6.022 times 10 to the 23rd atoms of sulfur. Units cancel out, moles of sulfur cancels out with moles of sulfur, and we're left with atoms of sulfur, and then we can go ahead and multiply. 3.5 times 6.022 times 10 to the 23rd atoms divided by 1, and when we do that, let me go ahead and get my calculator here. 3.5 times 6.022 times 10 to the 23rd. Okay, convert this to scientific notation. We're going to get this 2.1077 times 10 to the 24th. A lot of calculators like to give this e to the 24th, so this basically just means this number times 10 raised to whatever the power is. So this is 2.1077 times 10 to the 24th. And if you wanted to look at our, if you look here, our answer needs to be rounded down to 2 significant digits because this number here has 2 significant digits, this number has 4. Take the small number, answer needs to be rounded down to 2 significant digits. So we'll just take this and round it down to just 2.1 times 10 to the 24th atoms of sulfur. Okay, next problem. We have questions asking us 1.20 times 10 to the 24th atoms of sulfur is how many moles of sulfur. So let's go ahead and set this up. Moles of sulfur, and that's what we're looking for. What we're given is 1.20 times 10 to the 24th atoms of sulfur. Great. And then in order to get from atoms to moles, look back here, we're given that 6.022 times 10 to the 23rd atoms is equal to 1 mole, so we can use that as our conversion factor. So here 6.022 times 10 to the 23rd atoms of sulfur is equal to 1 mole of sulfur. And then our units cancel out, atoms of sulfur cancels out with atoms of sulfur here, and we're left with moles of sulfur, which is great because that's what we wanted. And then we can go ahead and start to plug this into our calculator, multiply the top, 1.020 times 10 to the 24th, times 1 divided by 6.022 times 10 to the 23rd. So we go ahead and do that. 1.20 times 10 to the 24th divided by 6.022 times 10 to the 23rd. It's equal to this number here. And in order to account for significant digits, this number has 3 significant digits, this number has 4. We ignore this, take the smaller number, this has, which is 3. So our answer needs to be rounded down to 3 significant digits. So this rounded down to 3 significant digits, this is going to be 1.99. So our answer is going to be 1.99 moles of sulfur. Alright. Okay, now this is a little challenging, these last 2 problems I have here, because we're going to have to go 2 steps, 2 conversion factors, okay? And you're going to see what I mean by that just in a moment. So this question is asking us 12 atoms of sulfur is how many grams of sulfur? Now before we even do anything, let's just look at this. This question is saying 12 atoms of sulfur is how many grams? Now we know that the mass of an atom is very, very small, okay? And we only have 12 of them. So we can just deduce that the mass that we get, or answer that we get, is going to be very, very small as well, okay? So a big thing here with these problems is that make sure you just use logic. Okay, if your answer makes no sense, like for example, we said that we wanted, let's say we do this problem and we get some huge number, some gigantic number, like just, I don't know, like 4 times 10 to the 24th grams. It makes no sense because we said, the question asks us 12 atoms of sulfur is how many grams of sulfur. It must be a very small number, you know? So just make sure you use logic in these problems, and that's a good way of checking your answers. Okay, so anyways, so let's get back to this problem. So we're asked how many grams of sulfur, so that's what we're looking for. and what we are given is 12 atoms of sulfur. Right, so from here, let's look back here at our first chart. So we got to go from atoms to grams. So first we're going to have to convert atoms to moles using our using Avogadro's number, and then from that, when you get to moles, you're going to have to convert moles to grams. So 2 steps. So first, let's convert atoms to moles. So here we know that 1 mole of sulfur is equivalent to 6.022 times 10 to the 23rd atoms of sulfur. And now we're at moles of sulfur, so from there we've gone from atoms to moles, from there we can go to grams. So we know from the periodic table that the average atomic mass of sulfur is 32.065, kind of hard to see here. You can look at your own periodic table and see that is indeed true. So since the average atomic mass of sulfur is 32.065, 1 mole of sulfur is going to have a mass of 32.065 grams. Okay, so we can use that as a conversion factor here. 1 mole of sulfur is going to have a mass of 32.065 grams of sulfur. Okay, now our units are going to cancel out. Atoms of sulfur cancel out with atoms of sulfur. Moles of sulfur cancel out with moles of sulfur, and we're left with grams of sulfur, which is what we wanted. Great. So from here, we can go ahead and multiply this out. Let me pull up my calculator. So multiply the top, so 12 times 1 times 32.065. Okay, and divide that by 6.022 times 10 to the 23rd times 1. 6.022 times 10 to the 23rd times 1. And then get that all together and we get this nice answer here. 6.39 blah, 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 times 10 to the minus 22. When we're accounting for significant digits, this number here, we're not going to use that in our significant digits because we have 12 atoms of sulfur, and that's a number that you can count. You know, you can count up to 12. It's very easy to count up to that. So this number is not considered in our significant digits because it's a counting number. Therefore, it has an infinite number of significant digits. So we ignore this. So we just we're really looking at just, you know, this number here and this number here, because these are numbers which actually have a finite number of significant digits. So this number here has 4 significant digits. This has 5. We're going to go with the smaller number, which is 4. And therefore, our answer should be rounded down to 4 significant digits. So, you know, when we do that, that is going to be 6.390. And that's our answer. Oh, wait. 6.390 times 10 to the negative 22nd power. I forgot about that. That's very important. 6.390 times 10 to the minus 22 grams of sulfur. And again, this answer makes sense because this is a very tiny number, and we started off with just 12 atoms of sulfur, so it should make sense that our answer is a very tiny number because the mass of 12 atoms of sulfur should be very small. Okay. Alright. Let's go ahead to our last problem right here. Final problem. Question's asking us 24.02 grams of carbon is how many atoms of carbon. So let's get the setup here. We want the atoms of carbon, and we're given 24.02 grams of carbon. Okay. So if we go back here, we're going to have to first convert from grams to moles, and then from there we're going to have to convert moles to atoms. Okay. So in order to convert from grams to moles, we know from the periodic table that average atomic mass of carbon, if you look very closely, is 12.011. So therefore, 12.011 grams of carbon is 1 mole of carbon has a mass of 12.011 grams. So we're going to use that as a conversion factor. 12.011 grams of carbon. 1 mole of carbon. So we're at moles of carbon here, and then from here we want to go to atoms. So we know that 1 mole of a substance is 6.022 times 10 to the 23rd. So 1 mole of carbon is equal to 6.022 times 10 to the 23rd atoms of carbon. And from here, grams of carbon cancels out with grams of carbon. Moles of carbon cancels out with moles of carbon. We left with what we wanted, which was atoms of carbon. And we can go ahead and now use our calculator here. So multiply the top. So 24.02 times 1 times 6.022 times 10 to the 23rd. Okay. And then divide that by 12.011 times 1. I'm going to get this. Let me convert this to scientific notation. Let me get here. So from here, let's look at our our significant digits. This number has 4 significant digits. This number, we'll ignore this 1 and 1 here. This number has 5 significant digits, and this one has 4. So our answer needs to have 4 significant digits. In order to do that, we're going to round this whole mess here to just 1.204, 4 significant digits, times 10 to the 24th. So that's our answer. 1.204 times 10 to the 24th atoms of carbon. Great. So, very simple, man. It's just, you gotta just make sure that you're first being very neat. That's my first tip. Second, make sure your answer you get at the end makes logical sense. And third, just make sure you understand this chart right here, so it's very easy for you to determine your conversion factors. At the end of the day, this is just dimensional analysis, but it's a little bit harder because of the new concepts we've learned with the mole. But as you can see, calculations using the mole when we're talking about atoms is as simple as that.